In last video, we talked about the structure and the layout of ELF, executable and linkable format. In this video, we're going to talk about how an ELF binary is executed by a computer. Recall that an ELF file is composed of four parts: ELF header, program header table, code and data sections, and section header table. Program header table and section header table are optional depending on the actual format of ELF binary. If the ELF binary is an executable, then section header table is optional. So actually, when computer executes an executable file, what it really cares is the segments coming from program header table. So the execution view of an ELF binary is actually header, program header, and code and data segments. On the contrary, if the ELF binary is for linking purpose, then when the linker is working on the ELF binary, it will neglect program header table. In this case, what it really matters are code and data as sections. Essentially, segments and sections refer to same part of the code and data. The only difference is that segments are used from execution perspective and sections are used from linking perspective. And in fact, a segment is composed of one or multiple sections. For Linux operating system, running an ELF binary means to call the executable by execve. The kernel will first load the executable into memory by program header table. So it will look at the information from program header table and load those segments into memory. And again, the computer gets the program header table by looking at the ELF header, and they then get each program header, which is a segment, by looking at the program header table. And second, the operating system will look for the PT interp entry in the program headers, which will point to the dynamic linker of the program. This is the program header that we showed in our previous video. And in this program header, the p_interp is the header in the blue frame. And as you see here, the headers point to the segment starting from bytes 238. And if you look at the bytes hex 238, you will find this exact string, /lib64 /ld-linux-x86-64.so.2. So this points to the actual program interpreter, and for ELF, the program interpreter is the dynamic linker. If the binary are in other languages such as Python, the interpreter will be different. And third, after the operating system figures out the interpreter, and for the case of ELF binary is dynamic linker, it will start to load dynamic linker. And dynamic linker will do the following stuff. First, it will map the shared libraries to the program's address space. Shared libraries, such as libc and libpng, are libraries that are pre-compiled and commonly used by different programs. So after shared libraries mapped into the program's address space, which can be accessed by the current executing program, dynamic linker will then relocate the text and data of those dynamically linked library into memory segment. In the end, the linker will relocate the symbols of the executable referred to the dynamic linked library. For example, suppose that we have an ELF executable which requires function printf. Printf is in library libc.so, which is a shared library. So in this case, the dynamic linker will load libc.so to the memory process. You may ask that what if there are many executables using libc.so? Does it mean that the linker has to always just load this library again and again and again? Well, Turns out that loading it is very expensive, and the operating system is trying to optimize it. The way that an operating system optimizes it is to check if the library is already in the memory. And if so, it will just map that memory into the new process space. If not, it will load the shared library first and then map the loading result to the new process space. Okay, at this point, Dynamic Linker has managed to resolve all the symbols that are required by the program from shared libraries. And now it's the time to start to execute the program. The operating system will look up the program entry from elf header and execute the program starting from the program entry point.